Hi, in today's video I'm going to explain the concept of combinations. And previously, if you have seen my videos on permutations deal with a set of objects that has to be arranged, and that it means in permutation the order matters. But in the case of combinations, we will see how this one is different to permutations. So from the term suggests, we're just getting a combination of a certain objects from a given set of objects. So for instance, if we have four people, say, we have person 1, or say person A, person B, person C, and then person D. So let's name them person A, person B, person C, and person D. Suppose this group of people is or are members of a varsity team, and the thing about this is that they were invited into a tournament, so they will be joining a tournament, or they were able to receive an invitation to join a tournament. However, out of these four members, the invitation said that they can only get three, or they can only send three members from the team. So the problem of the coach now is to know how many possible combinations can he form in to decide who to send in the tournament. So this is a question about combination. So from four people, you're going to form three members. So that's basically you're taking three, taking three out of four. Okay, so how do we do this? Now for small numbers, I think that this is still fairly easy to identify such combinations. Maybe the coach can send person A, B, and C together, or A, B, D together, or it could be A, C, and D together, or B, C, and D together. So he could form four groups coming from um, four people. Okay, getting three people coming from four people, and again, as you can see, it's still easy. But the problem is, what if we already have a large number of people to choose from? Like we have 50 members, or let's say just 20, and you have to get five from those 20 people. So I think listing them, or listing down the possible combinations, could take some time, and it's possible that you will be missing a group. So how do we make this counting easier? So we introduce the concept of combinations in terms of a formula. So for combinations, we use the symbol. So there are different ways to indicate a combination. We sometimes you see a C and K, or you simply see the symbol N and K with a parenthesis. So the meaning of this is that we are going to get, so from N objects, we are going to get K objects. So in our example, the N is like the 4 is like our N, and then taking 3 from the 4 members is our K. So the formula for the combination is the NK. This is pretty similar to the permutation formula. You get the n factorials, and that is your n, and then you subtract n and k, then put factorials, and then there is this k factorials also in the denominator. So Again, in some books, the K could be a different letter. It could be an R, it could be an S, it could be a T. Okay, so don't be confused when you see a different letter used in a given formula. They just mean the same thing. So how do we apply this and verify that what we have taken a while ago, four groups of three from four members? So let's see how this can be used. So 4 is our N and 3 is our K. Again, there are 4 members from the varsity team, but we can only send 3 members in a tournament. So we have 4 taken 3. So n factorials means 4 factorials, and then n minus k is 4 minus 3 factorials, and the k is 3, so we have 3 factorials. And then simplifying this further, now my tip is when you see a lot of factorials, do not expand it yet, meaning to say, do not change 4 factorials into 4 times 3 times 2 times 1, although that's the meaning of the 4 factorials, but rather, just simplify first the one in the denominator, that's 4 minus 3, that's 1 factorials, and then 3 factorials. And try to observe. You have 3 factorials in the denominator, and you know that 4 factorials can be written as, this will be 4 times 3. Now you can continue times 2 times 1, but I think it is best that you just keep the 3 times 2 times 1 as 3 factorials. Again, 3 factorials is 3 times 2 times 1, but do not write it as 3 times 2 times 1. You leave it as 3 factorials because what will happen is that if you keep that as 3 factorials, you can simply cancel the 3 factorials in the denominator with it, right? So we now have 4 in the numerator. 1 factorial is 1, so that's 1, so this is equal to 4. So this verifies the answer to our first example. In how many ways can you form 3 members out of 4 members in a varsity team? And earlier, we just listed the possible combinations. And again, if this will be a large number of members, it is possible that we will be missing a group. So to make it more systematic, we use a formula which is nk, n factorials over n minus k factorials times k factorials to get the exact number of combinations. Okay, so let's apply this to one more example, okay, to get to understand, okay, how this can be used in solving problems. Let's change it a bit. Suppose we have 12 people in a group. Say our example now is, so this is example number 2. There are 12 people in a group, but in this group we have, let's say, 3 female. So that means we have 9 male, okay, or 9 boys and 3 girls. Now suppose you were tasked to form, so I need you to form a group of 5 people, okay, and then there is a condition that in that group I need 1. So in that group, so from 5 I need exactly 1 female. Okay, every time I form 5 people, I need 1 female. Okay, so how do we apply the concept of combination in this question? Okay, so take note that the 12 members were divided into 9 because there are 9 males and then 3 females. Now focus on the condition. Okay, what you want is from the group of 5, there has to be 1 female. So you need to take 1 female from the 3 given number of females. So that leaves 4 people that can be taken from the group of male. Okay, why 4? Because again, you want to form a group of 5 people. You already have 1, so you have 4 left to get from the male group, and you're getting it from the 9 males. Okay, now what are we going to do with this 9 taken 4 and 3 taken 1? Okay, applying the fundamental counting principle that states that the number of ways is that the number of ways for the male should be multiplied to the number of ways for the female. That is why the operation in between is multiplication. Okay, so it's like R different ways, and then the other group is S different ways. Then the total number of ways is R times S. This is the same case here. 9C4 times 3C1. And this can be solved using the formula. So we have 9 factorials over 9 minus 4 factorials times 4 factorials. And this is times. So our n in the second is 3. So 3 factorials. 3 minus 1 factorials times 1 factorials. Then you continue by simplifying the expression. Leave the 9 first. Do not make it 9 times 8 times 7 times 6 up to 1. So you have 9 minus 4. It's 5 factorials and 4 factorials. This is 3 factorials over 2 factorials. 1 factorials. And this is the time that you have to decide up to what number should you expand the 9 factorials. Of course, you will extend it only up to 5, because at that point we will be able to cancel 5 factorials. So this means 9 times 8 times 7 times 6 times 5, and then you stop at 5 factorials over 5 factorials, 4 factorials. Then you have 3 factorials. Or we can change this now into times 2 factorials over 2 factorials and 1 factorials. Then you just have to cancel 5 factorials and 5 factorials, 2 factorials and 2 factorials. Now this 4 that you see here can be changed to 4 times 3 times 2 times 1. And then try to spot numbers that can be cancelled. 8 and 4 becomes 2. That 2 and this 2 will cancel. 9 and 3 becomes 3. And then 1 is just 1. So we have, let's simplify that into 3 times 7 times 6 over 1 times, here we have 3 over 1 factorials is 1. So this is just 3 times 7 times 6 times 3. Okay? And finding this value, this is equal to 378. So can you just imagine if you have to think about, listing, if you have to list down all the combinations, you will need 378 combinations, and that will take some time. Okay, but using the formula, we were able to find the exact number of combinations that can be taken from the group of 12 people. Okay, considering that we only want one female member, and then the rest can be 4 from the boys. Okay, so in this video, you're able to see an example, a basic example on how to apply the combination formula, and also the understanding the idea of combinations at the very start of the video, in which I showed you an example with 4 members, and then you have to take 3 members from them. Then again, we said that we can use listing if we have a few number of people. But if you have a large number of people already, then I always suggest that you use a formula. In the second example, I have shown something more than just using the formula once. So it's a combination of, a 9C4 and a 3C1. And then we apply the fundamental counting principle to really find the exact number. So we have 9C4 and 3C1 on the other. So what should we do with them? We have to multiply by the fundamental counting principle. Then we apply the formula properly and then simplify until we reach the desired value. So there are 378 combinations. Okay, so again, the difference between combination and permutation is that in permutation, there's always an arrangement, the order matters. In combinations, you're just taking a group, okay, or taking members to form a group from a given set of group objects or people, okay. Combinations ABC is not different to CBA because again, arrangement is not important. Okay, so I hope you understand the concept of combinations at the basic level. There are other advanced questions about this, which I will try to create more videos for these examples. Okay, so that's it.